Hello, everyone. We'll be starting the session. Good morning, good afternoon, good evening. Dear authors and invited guests, welcome to the technical session 14B. Myself, Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology ICICT 2025 London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18 February in London, UK, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we will have 6 presentations, and each presenter will be given 12 minutes for the presentations and 3 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. In this session, there is another request to all the participants that you stay connected with us till the closing remarks. If you have any query or any update, then you can write it to me in the chat box below. Just before we get started with the session, I would like to introduce you all to the chair for this session, Professor Sama Senbale. Ma'am is an associate professor of computer science and engineering at Sacred Heart University, United States. She specializes in programming, data structure, distributed systems, web programming, and operated systems. Her research focuses on data analytics, distributed systems, and cloud computing. Welcome to the session, ma'am. Would you like to share a quick opening remark with us?
Yes, good morning or good afternoon, everybody. It's my pleasure to be here today. And I looked at the titles of the papers, and I think this is going to be a lovely session. So thank you guys for joining.
Thank you so much, ma'am. I would also like to take a moment to introduce you to our session chair, Dr. Navneet Sharma. Sir is an associate professor at the Department of Computer Science and IT at ISS University, Jaipur. He has 17 years of teaching experience of UG and PG classes, associated with various research associations and universities and consultancy services. Associated with more than 15 universities for various academic works, including PhD, thesis evaluation, etc. His research work on e-commerce, cloud computing, network securities has more than 25 research papers published in various international journals. Welcome to the session, sir. Would you like to share a quick opening remark with us? So we are unable to hear you. No, sir, we cannot hear you. No, sir, we cannot hear you. It's okay, sir. You can type it in the chat box if there is any problem. No worries. Okay, sir. Okay. Thank you, sir. So first up, we have B. Kiran Bola to present the paper title, A Deep Learning Approach for Proactive Detection and Mitigation of Zero-Day Attacks in IoT Environment. Are you there? Are you there, Mr. Kiran? Okay. So we will be moving on to the next presentation. Next, we have Freedom to present the paper title, Development of Artificial Intelligence-Driven Web Applications for Detecting Maze Diseases. Are you there, sir? Freedom, are you there? Okay. So we will be moving on to the next presentation. Next, we have Abdul Rahman to present the paper title, Machine Learning Approach for Liver Disease Prediction. Are you there?
Yes, I'm here. Thank you.
Yeah, you may please start with your presentation.
Okay.
You can share your screen and start with the presentation.
Yeah, I think my computer camera is not working. Is something unusual happening?
There is no problem in that. It's okay. If there is any problem, you can just share your screen and start with the presentation.
Yeah, okay. Okay, now I think it's the screen share now.
No,
You hear me?
no, we cannot see your screen as shared. Can you please share it again?
Okay. You should. Okay, now. What about now?
Yeah, we can see your screen as shared. You may begin now.
Yeah, okay. Okay. Hello, good afternoon, everyone. My name is Abdul. I'm here to present my research on machine learning approach for liver disease. This study explores how machine learning algorithm can assist in the early detection of liver disease, which are significant global health concern. Let's go to explain the here we are going to talk about introduction. Liver disease are going concern to world with the cases ranging from the poor lifestyle choice to excessive alcohol consumption. Early detection is critical for effective treatment, but traditional method often fail to identify issue to early stages. In this study, we evaluate how machine learning algorithm can protect liver disease using clinical data, aiming to improve early diagnosis and patient outcomes. Let's talk about why this is important, methodology and motivation and challenges. Liver disease often goes unnoticed until it reaches advanced stages, making early detection a significant challenge. Furthermore, the lifestyle factors can limited awareness and contribute to the rise in chronic liver disease. Using machine learning, we can analyze large data set to detect patterns and predict disease risk. We addressing these challenges effectively. Let's explore some key research and findings relate to this subject. Several studies have explored machine learning for disease protection. Well, algorithm like logistic regression or and key nearest neighbors have showing potential. The random forest and support vectors machine have often outperforming others. However, profile studies have faced issue with the imbalance dataset and Flaric feature selection method, which our study addresses. The methodology here, we use dataset, the UCI repository with the 1,385 samples, contains clinical and personal data about liver disease. Our methodology included that data and pre-processing to handle missing values. Normalization to ensure consist skills and feature selection to identify the most relevant attributes. Finally, we applied 5 machine learning algorithms to protect liver disease. The machine learning models, we evaluate 5 algorithms here: logistic recognition, key nearest neighbors, support vectors machine, decision tree, random forest. The first one, which is useful, primary outcomes, key nearest neighbor, which classifies a database to proximity to similar cases. Support vectors machine, known for its robustness to handling linear and non-linear data. Decision tree, which over clear to hierarchical classification process. Random forest ensemble method companion multi-decision tree for better accuracy. Each algorithm has strength and weakness, which we compared in detail. We used performance. We used four key metrics to evaluate performance: accuracy, which measure overall correctness; precision, indicting the reporting of the true positive among protect positive. Recall on the ability to identify all actual positive. F1 score, balance between precision and recall. These matrix provide comprehensive view of the model effectiveness. We're talking here about result overview. Our result showing the random forest achieved the highest accuracy of 87.876%, followed by other models like support vectors machine and key nearest neighbors. Random forest also excelled in precision, recall, and F1 score, making it the most reliable model for the precision liver disease. Here we're talking about the findings or decision. These findings highlight random forest strength in handling imbalance, dataset, and ability to avoid overfitting. While other algorithms performed well, they lacked of the consistency and robustness of random forest. This demonstrates in the importance of model selection and feature engineering in the machine learning. Visualization here. Here you can see the comparison of model performance in terms of accuracy and precision, recall, and F1 score. The ROC AUC accuracy future validate the effectiveness of random forest, showing the superior ability to distance between positive and negative case of liver disease. Here we conclusion about this study demonstrate the potential of the machine learning in protection liver disease. Random forest emerged as the best performing algorithm, achieving high accuracy and robust metrics. These findings can guide healthcare to professionals in early detection and intervention ability, saving ultimately saving lives. The future research should focus of using large and more drives data set to improve model generalization, to incorporating additional clinical and genetic feature could also enhance protection. We're exploring advanced technology techniques that deep learning may future improve the accuracy and provide new insights into liver disease protection. Thank you for listening. This is my presentation.
Thank you so much for your presentation, Abdul Rahman. Sir and ma'am, do you have any questions?
Yes, please. I have a question. Can you tell us a little bit more about the data that you used? So you said you had 1,385 rows. Can you tell us a bit, what do you know about those data?
Yeah, actually, the random, the random forest algorithm work the best. It gives the highest accuracy of the 87.76 and early liver disease protection. Also, because the random forest is used because it can analyze medical data. Specialists detect liver disease early, which improve the chances and recovery.
Great, thank you.
Thank you so much, sir. Do you have any questions? Sir, do you have any questions? Oh, we are not able to hear you,
Yeah.
sir. Yeah,
Excuse me, can I have a question?
yeah, sure, sir. You can have a question.
Okay. The author said that the random forest has the performance of random forest is better than the other type of machine learning. Could you please justify why you think random forest is better? Thank you.
From the UCI library containing 1,385 samples, which medical test results related to life health. Also, it's help specialists detect liver disease early, which improves the chances of recovery. Also, the random forest algorithm work the best. It's give the highest accuracy. Yeah.
Thank you so much.
Thank you. Thank
Uh,
you.
Am I audible now?
yes, sir, Navneet, sir. Yes, you are audible. Please go ahead.
Can you show your visualization on the comparison of all the algorithms? Abdul Rahman, you getting my voice?
Yes, I hear you.
Yes. Can you show your visualization that is not mentioned in your slide?
Yeah, maybe
Data visualization.
because something wrong in my computer.
Okay.
The random
So what were the parameters you have implemented on these ML
yeah
algorithms?
yeah because the random forest, then SVM, then key NN 81 20%, decision tree 80
Any specific parameter on which you have compared all these algorithms for
yeah
liver functioning?
sorry, I cannot hear you.
So you're audible. Can you please repeat?
There is some background sound. Can
Yes,
you,
sir. Your voice is getting cut in between. Otherwise, it's fine. We can hear you.
there is some background music is on. Can
Yeah.
you mute that music?
No, sir. We have no background music going on.
Okay.
Okay. Great. So we'll be moving on to the next presentation now. Next up, we have Fu Hong to present the paper titled Machine Learning for Anomaly Detection in Auditing and Financial Error Detection, Methods and Practical Applications at the Thai Nguyen Province. Are you there? Fu Hong, are you there? Okay. So we will be moving on to the next presentation then. We have Aman Musa to present the paper titled Parameter Efficient Fine Tuning of LLMA 2 for the Kazakh language, Advancing Low Resource Language Models. Are you there?
Hello, yes, I'm here. Can you hear me?
Yeah, we can hear you. You may please begin with your presentation.
Okay.
Okay, I'll just allow you to share your screen. Give me 2 minutes. Yeah, you can share your screen. Yeah, great. We can see the screen being shared. You must begin your presentation.
Okay.
Thank
Hello, everyone. Dear professors, dear students, and this is Amma Musa from Kazakhstan and from the Al Farabi Kazakh National University. And today my topic is about the parameter efficient fine-tuning of Llama 2 model for Kazakh language, advancing low resource language models. So I think, as everyone knows, this is the era of AI because the tech giants and the others, they plan to spend more than $1 trillion on AI capital expenditures in the coming years. So they are going to spend on the more than $1 trillion. This is said by the Goldman Sachs company. Why it could attract such huge investment? Because in the past years, past several years, there are many. It's like the excellence models there have been published, being released, and it bring a huge impact to many aspects in our life. And you can see here is an organization that adopted AI in the last one business functions. So there are more and more companies, they start to adopt AI in their processes, in their procedure. And why it's so popular? That's one reason is that it changed the way of the how people interact with computer. Because in the past, when people need to develop the business content, they need to solving programming problems or creating a song or a poem. They need to do many things like they need to do the long-term reading and studying of material. They need to search for information for multiple resources, and it really spends time. But if use the large language models, it's just used to people just could describe their problem, like just give them instruction, like tell the GPT or tell the other models like what you need to do, and it should match what kind of the requirements, and the LLMs could be able to offer the solutions. So why became so popular in the past several years? Because due to the one reasons is because due to the scaling law. That means the larger the better. We all know that large language models they are the based on the transformer neural networks. Uh, People find that when increase the number of the parameters and its performance will get better. You can see in the past 2 years, its performance increased from 30, now it's even close to 80. It's more than 80%. So you can see the performance or the abilities of the AI that increased 2 times, even 3 times than 2 years ago. And that's why it could attract such more investment, and it's so convenient. And even the Bill Gates said that AI is revolutionary as personal computers, mobile phones, and internet. We know that in the past, this kind of like the PC with mobile phones with and the internet, there are become such more big companies, and now all the big companies they start to invest AI. And now we know it's when the large language models have the more parameters, it could have better performance. But the problem is that it's like when the parameter number get increased, the requirement for the computational resources or the computational power also get very high demand. For example, here, full to to the training the Llama 2 with 7 billion parameters, here needs the 100,000 GPU hours, which is for the this is for the A8 NVIDIA GPU. It stands for $18,000. So I need to buy a GPU which is stand for almost $20,000, and I need to train it for 180,000 hours to training a model. That means if I only have one video card, I need to it's like train it with the 21 year. So you can see it's so hard to train it. So that's why we need to find a way that to make it more efficient, make it to easier to fine tuning, make it easier to train. Because when we train to the BERT model or the Roberta model, it's now just like it just will be finished the training processes maybe several hours. But to training the large language models, we can see it's like thousands of the GPUs, a very grateful clusters, and we can finish the training processes. And we can see there is another challenge for the low resource languages, because you can see nowadays it's like the many website content are just in English, in Spanish, in German, and of course most of them are just based on English. And the language like because I'm from Kazakhstan, the Kazakh language are just take less than 0.5%. So it's harder to collect the data, because if to training the models in English, there are many already done, they already knew data set. But in Kazakh language, there even it's hard to parse the data from the internet. And you can see when also when the big giants they training their models, you can see the language distribution in pre-training data, which is have the percentage greater or equals to 0.005 percentage. So you can see English language still takes more than 80%, 90% of the training data, and the German language and the other language, they only take even less than 1% of their training set. So this is so that's why we need to find the parameter efficient training, and also we need to focus on the low resource language, and that's why this is our goal. We need to solve this question. So what is a parameter efficient fine tuning? That means people use the 5% computational power and keep the 95% of the performance. So nowadays there are 4 main methods to train the model in a very efficient way. The first one is a low rank adaptation. The second one is adapter-based tuning. The third one is prefix tuning. The last one is prompt tuning. It's like the LoRa, they will firstly froze the base model and connect two matrices. And when every training just updates the two small trainable matrices, and the parameter will get updated. So compared than updating 7 billion parameters, now with the LoRa, low rank adaptation, we just need to adapt it only thousands of parameters. That's very efficient for most organizations and the individuals. And the next one is adapter-based tuning. The adapter-based tuning is like just add an adapter in their transform layer. So when every time the model get trained, just update the block which inserted to the transform layer. The next one is prefix tuning. That means we need to add a small prefix in the key and the value vectors in the transform layers, because we know in transform module it has the q, key, v, three vectors. And in the last one, prompt tuning, here we have the input. What we need to do is just add the input sequence and add our prompt. So every time when training the model, of course, the parameters of the model will be frozen, and we just need to update the prompt. So that is why it's called prompt tuning. And now here we just take the LoRa low rank adaptation. Just let's see why we need to do that. If we use full fine tuning, that means we need to update all the parameters of the model. That means we need to update 7 billion parameters. We need to use hundreds of thousands of training hours to finish it. And if we use LoRa, you can see we will just use mixed precision solutions, because when training data, because we need to put the data into the CUDA or the tensor, if it stands for 32-bit, it takes really much more time. But if we use the low rank of it, like we use only 8 bits, it could save up many times, and we could just update the model, and we update it
Sorry
in a
to
very
interrupt you, sir, but you have 2 minutes to conclude your presentation.
okay. Just last pages. So and then we need to the instruction tuning. So in the nowadays, there are 2 stages in the training models. The first stage is unsupervised pre-training. It's usually from the raw text to learn the general purpose representations. And the second stage is large-scale instruction tuning and reinforcement learning to better align with the end task and the user preference that make it to match the human value. And you can see here we have the instructions. That means what we want the model to do and input. The text or context the instruction applies to. The last one is output. That means the ideal response to the instruction. That means what we want the models to answer. So here we just use a very efficient way to update our model. But however, here we have still some problems, because Kazakh language is a low resource language. We still lack of the standardized benchmark. It could be doing in the future works in a more detailed way. So thank you. Do you have any questions?
Hello, yes, I have
Thank you
two
so much
simple
for your
questions.
presentation. Ma'am, you can ask your questions.
Yes, please, I have 2 questions. How long did it take to train your model, and what kind of data were you using? You said you collected 40,000 data. Where are they from, please?
Here it's just from the machine translation. Just machine translation. I translate this from the English dataset, and I also generate from the GPT 3.5. I just insert some prompt and ask it to generate the data like the you can see like this
I
one.
see.
It could just but it will just output this like in Kazakh language, not English. And because here I use the 4-bit training, it takes like I do it in the 24 GB video card. It takes more than 1 day, like 20 hours to
Oh, wow.
training it into Epoch.
Okay, thank you.
Thank you too.
Thank you so much. Sir, do you have any questions? Okay, I guess no questions then. So we'll be moving on to the next presentation now. Next up, we have Pablo to present his paper titled Service Linguistic Features for Multi-Class Fake News Detection into a Multilingual Context. Are you there, sir?
Yes. Do you hear me?
Yeah, we can hear you. You may please begin with your presentation.
Yeah. I'm using the camera, but I don't know if
It's
you
okay, sir.
can see.
You may share your screen and begin.
Okay. Please let me know if you can see the presentation.
Yeah, sure.
Then okay. Now I'm sharing presentation and I'm using full screen. Yeah,
Yeah,
I'm
we can
okay.
see your screen. You may begin.
Okay. Uh, well, hello. My name is Pablo Ormeño. I'm from Chile. And today I'm going to do my presentation of the work me and my colleagues have been working the past year. The title is Surface Linguistic Features for Multiclass Fake News Detection in a Multilingual Context. My name is Pablo Ormeño. Then, the agenda is the following. We have the introduction, the background of the topic, the methodology we use, the experimental setup, and the results and discussion. Yeah. First, our work is about fake news and their impact in the influence of the people's thought and opinions. Yeah, these types of news has a social influence, political influence, and sometimes economic influence. So when we went to make some semi-automatic machines to make classifications, we have some problems in case of binary classification and multi-class classification, especially when the data sets are imbalanced. When the data set is imbalanced, we have a problem to detect the minority class, especially with the fake news class, right? And we have the next problem is the multilingual complexity. When we found about the same topic, multiple languages, yeah, and sometimes this offered extra challenges due to the linguistic differences, yeah. We propose now an approach who is independent of the language on the language we are using language features to improve the detection, and we want to introduce in this work some technique to approach this problem, right? So we are trying to use surface linguistic features to detect fake news across multiple languages, right? The fake news has simple structure, and we have the problem that this spread online very quickly. So the importance to detect this is crucial. Yeah. These data sets, or especially the fake news, has the problem that they are imbalanced, and that make difficult the detection when we use machine learning models. Yeah. Uh, when we have balancing techniques when we manipulate the samples, and with this we can improve the minority class and detect the important class we are trying to detect. Yeah. And this to this problem, we can add the multi-class and multilingual approach to enhance this detection, yeah, and make these kind of machines more reliable, right? So this is our methodology. We have the data set, we extract the linguistic features in different data sets with fake news, and we try to perform this classification, this multi-class classification. Yeah, we extract the linguistic features, and then we pre-process the data set, and we have this imbalanced training set, right? We use state-of-the-art machine learning models like AdaBoost, Random Forest, and XGBoost on this dataset, imbalanced dataset, and we found that the performance of the method sometimes indicate that the detection of this kind of data is difficult. For that, we applied balancing techniques like SMOT or ROS and RUS, oversample and undersample, to improve this performance. And with this, we try the set extracted from the same data set, and we prove the metrics for this, right? These are some of the of the of the surface variables, linguistic variables, we are trying to perform this classification. We have numeric values about the number of sentences, the number of paragraphs. We have means values, standard deviation values, etc., etc., etc. These features are extracted in different data sets, and we can make some new dimension to analyze this, right? The dataset we are using are two, one in English, Liar, and one in Spanish, CL News. The Liar contains 12,000 verified statements in 6 classes. And the CL News includes 300 tweets with true, false, and rumor verification. Yeah. For this experiment, we used 3 categories for Liar and 4 categories for CL News. And we compare the performance to make this analysis, right? Here are the results for the Liar dataset, where we can see the difference, especially in the confusion metrics for AdaBoost when for the imbalanced value, the imbalanced dataset, we have a very explicit performance in the true news. It's important to say that the balance between both of the data have a lot of occurrences of the true news, as it happens in real life. When we apply the different values, the different techniques of sampling, we have improved in the detection of the different false and past fire that is news with when we don't know what kind of news is, we put it in this category. If you can see, the values of recall and accuracy improve in some cases, and that indicates that the data, the classes, the interest classes improve. The same for the CL News, the Spanish dataset, where we have improvement when we try to detect the 4 categories. As you can see in the confusion matrix for Random Forest, we have a lot of detections in the diagonal, indicating that the improvement occurred when we try to balance the dataset. As you can see, in Liar and in CL News, the values of accuracy, precision, recall, and F1 score improve in some cases when we balance the datasets. Yeah, as you can see visually in the confusion matrix. I missed one slide, so I can talk about it. For discussion and future works, we would like to try different approaches, especially when as you can see, we have different kind of classes here. So we would like to try an approach when we have the same number of classes and try to mix both both languages and try to detect, independent of the language, what is the performance of the approach. For future work, we would like to try different languages, especially languages different from Spanish and English, for maybe French speakers or Russian speakers or Japanese speakers, and try to approach with the same kind of features, and understanding that the language features are the same in some cases. Thank you.
Thank you so much for your presentation. Ma'am, do you have any questions?
Yes, please. I just noticed that the results you have are very different for the English dataset and the Spanish dataset. They're actually the opposite. One time the balanced is better, one time the other is balanced. Do you have a reason for that? Why are they
Yes,
so different?
thank you for your, sorry.
Go ahead. Thank you.
Thank you for your question. Yes, we noticed that we have some difference in the results. The main reason we think that, as I said, we are using different number of classes, yeah, and the imbalance, yes, is different. For example, CL news, as you can see, the rumor class is greater than, for example, the false news class. Here, the difference, you can see it in the past fire news. That is a class we don't know if, or we cannot categorize in true or false news. So the imbalance is different, and also the language features may be different in both languages. So the future work is to try to find language features that can be similar in both languages, and with this, we could try to understand the similarities in different datasets.
It's very interesting. Thank you very much.
Thank you so
Thank you
much.
for your question.
Sir, do you have any questions?
No, not from my side.
Okay, so we'll be moving on to the next presentation then.
Thank you.
Thank you. Next, we have B. Kiran Bala to present the paper titled A Deep Learning Approach for Proactive Detection and Mitigation of Zero-Day Attacks in IoT Environment. Are you there now?
Yes, ma'am.
Yeah, you may please begin with your presentation now. Are you able to share your screen? Yeah.
Ma'am, but yeah,
Yeah, we can see your screen being
yes,
shared.
ma'am.
Yeah, please start.
Yeah, thank you, ma'am. So first of all, thanks for the organizing committee for giving me a wonderful opportunity to present here. Myself, Dr. Kiran Bala, I'm head of Department of Artificial Data Science from K. Ramakrishna College of Engineering, India. So my paper title is a deep learning approach for a proactive detection and mitigation of a zero-day attack in IoT environment. Though the contents and the list of things which is available in my presentation is so abstract introduction, literature survey, problem definition, proposed work, methodology and implementation, results and discussion, conclusion, references. So these are the things which is available in the contents. The first we are going to see the abstract. The Internet of the Things, that is IoT, is becoming a crucial component of many industries, from smart cities to healthcare. In today's the network world, so the IoT devices are becoming more and more. It is going to be a very risk factor, especially with the zero-day attacks. While take advantage of undiscovered flaws, the dynamic and disparate nature of these systems make it difficult to identify and migrate these assaults of an IoT context. The involvement of the attention mechanism help to focus on most relevant feature, enhancing its efficiency and reducing the computational overhead, make it a promising solution for a real-time security application in IoT systems. The result demonstrate how deep learning may improve the IoT system security posture by offering a proactive real-time protection against zero-day threat, resulting in a safer, more robust IoT environment. So in the introduction part, so we have developed a auto encoder based anomaly detection system. So the research introduced an autoencoder model trained on normal IoT traffic to detect zero-day attack by identifying anomaly through reconstruction error, enabling the detection of novel and previously unknown threat without relying on a labeled attack. The integration of attention mechanism for enabled detection. So just by incorporating a mechanism into the autoencoder architecture, the study improved the model's ability to focus on critical feature in a network traffic, such as unusual packed sizes or irregular flow pattern, thereby enhancing detection accuracy and reducing the false positive. In the real-time detection for dynamic IoT environment, the proposed approach emphasizes the real-time detection of zero-day attack in a large-scale IoT networks. The demonstration the scalability of the autoencoder model with attention mechanism to efficiently handle the vast volume of IoT traffics. So in the literature survey, the first paper which the confirmed the detection approaches dependability in the event of an assault on which had not previously receiving the training. The study of CNN classifier capacity to detect malicious attack traffic, especially zero-day attack, where are assaults that non-bear are discovered. According to the experimental finding, employing regularization technique improves performance across the board when compared to the conventional CNN. The second paper, they suggest using the autoencoder to identify the attack. NSL KDD and CICID 2017, two popular ID datasets, are utilized for assessment. When zero-day assault differ from typical behavior, the performance of a one-class SVM is highlighted in the article. In the another paper, so they had effort to heterogeneous attack to teaching the necessary empty methods. In the real world IoT sensing scenario, it is accomplished utilizing the Raspberry Pi acting as a spectrum sensor. So the reviewed studies represent a critically limitation to the zero-day attack detection and migration techniques. While regularization is an improvement over CNN classifier for the detection of zero-day attacks, autoencoder achieve a good accuracy in a zero-day detection for some dataset, although there is a effectiveness against in a dependent on the network environment in question. Hence, the limiting the generating. Despite that, CNN outperformed the traditional machine learning in IoT zero-day attack detection. The need for diversity training data sometimes become a challenges to high precision data. The most MTD frameworks defeat most attack inside the IoT device with the real source constraint. Here, the problem statement. The problem examined in this study is how to find attacks in IoT because the malicious activity come with unknown or novel pattern. So that cannot be identified by the traditional signature based detection system. So it is referred in the paper. So diverse the cyber threat, including the botnet driven attack and the DDoS incident, are also created by increasing the complexity and scale of IoT environment. The current detection mechanism failed to adapt to these new unseen attack vectors. So there is a pressing need for a powerful adaptive solution. The above research will develop an autoencoder based anomaly detection system enhanced with the attention mechanism that will find such unknown thread through the pattern analysis of network traffic without relying on a labeled attack data in order to eventually increase the security in on the IoT networks. So the proposed methodology, proactive detection and mitigations of zero-day attack in IoT environment. So here we are having a BOT and IoT data set. Now what we are going to do is we are going to clean the data, feature engineering, data pre-processing, data splitting, normalization and scaling. All will take care in this part. Then we are going to have a auto encoder based anomaly detection. Then we are having a enhancing the zero-day attack detection with the attention mechanism. Finally, we are going to evaluate the performance evaluation. So this is the proposed methodology of the proactive detection and mitigation of the zero-day attack in the IoT environment. So first, data description. For data collection, the data of a BOT and IoT is considered that offered realistic network traffic data generated from IoT settings both with normal and biotic traffic. So the BOT under score the IoT 2022 very board attack category is implemented as a part of dataset and is considered a very essential for training the and testing of deep learning based model for the detection of attack. Next, the data set pre-processing. So in cleaning the data for BOT IoT data, the missing values need to be detected, and we have to eliminate the rows and columns that have a huge number of missing values. Outer layer detection is also the essential for removing extreme value that should be significant for feature like packet size and flow duration. Noise reduction is also required for impossible or inconsistent record. Example with include zero duration flaw or negative packet counts that are necessary for proper model training. The feature engineering, it is quite useful in the BOT IoT dataset for improving the data detection. So improving the data detection. Then we are having a essential extraction size of a packet, flow duration, protocol type, and pattern in a traffic from raw data. The feature selection related to the selection those features that are most relevant for detection purpose and deleting the irrelevant one in the process. Normalization scaling, we are having a normalization standard n minus n minimum and n max minus n minimum. Data splitting, a train split, validation split, and a test split of the data are established. These splits can be used to the train the local models. So here the auto encoder based anomaly detection for 0-day attack in IoT environment, and auto encoder for finding the IoT environment 0-day attack learn to reduce the representation of normal traffic using an auto decoder architecture. Since this form of attack is a novel, it is a very hard for this type of attack to captured by the signature based system. Therefore, an auto encoder is trained solely on normal traffic data in order to grab the kind of behavior and flow across the network. Once trained, the autoencoder could identify the anomaly based on reconstruction error from original and reconstructed traffic. So the approach is deal for IoT network because it work in a detection of unknown threat without the label attack data. Next one will be the enhancing the 0-day attack detection with the attention mechanism in IoT environment. The attention mechanism plays an important role in improving the performance of any AE used for classification in the context of IoT environment, since it allows the model to set emphasis on what are the most critical feature of the input. So this has the effective dynamically assign higher weight to those critical features likely to indicate the anomaly behavior like unusual packets, irregular flow of packets, or unexpected traffic spikes, which are all the common indicator of the 0-day attack. All these help the model focus on the proper information, thereby increase the detection accuracy and computational efficiency. So integration and auto encoder, see, an attention mechanism can be added inside the auto encoder architecture, usually between encoder and decoder. The auto encoder will learn to encode the data into a lower latency space using the encoder and then reconstruct it with the help of the decoder. With the additional attention mechanism, one can enhance the selectiveness of the encoder and focus on which is most representative and critical with regards to the normal and abnormal behavior. In practice, this attention mechanism will modify the encoding process such that reconstruction error become more sensible to informative features of the input data. See the result and discussion, the performance metric graph. So with respect to the accuracy, precision, recall, and F1 score, auto encoder plus attention, so it has been shown in the graph. See here, feature input. The average attention weight with respect to the feature, we are having packet size, traffic volume, flow pattern, source IP variance, and destination port. So it is a feature importance for the 0-day attack detection. So the we are having with respect to the feature of packet size, traffic volume, flow pattern, source IP variance, and destination port. So here the reconstruction error distribution for a 0-day attack detection. See normal traffic which has been indicated in green and anonymous traffic 0-day which has been indicated in red. So frequency versus reconstruction error, it has been showed in the bar chart with respect of the reconstruction error distribution for 0-day attack detection. Here the methods we are having STL plus FBM. SVM and AE plus DNN, and we are having AE plus attention. So with respect to accuracy, precision, recall, and F1 score. So this is the performance comparison. So for this AE plus the attention, we are having the good result with respect to accuracy, precision, recall, and F1 score compared to the STL plus SVM and AE plus DNN. So the discussion to enable deploying the model on a device with limited computational capability. So compensation strategy of model quantization are possible. These approaches help to decrease the size of the model through reducing the weight and the network structure while.
Sorry to interrupt you, sir, but you have 2 minutes to conclude your
Yes,
presentation.
ma'am. Yes, ma'am. While allowing the fitting of a complete model onto the device, minute memory of an IoT gadgets with little compromising on its efficiency. So the moreover, the knowledge digitalization can be applied in the construction of the spare models, which are accurate as the large models. Moreover, the attention mechanism is the proposed model is also aiming at minimizing the possible computational overhead, since the model attention is concentrated only on the essential input data. This makes the model more efficient and improves the latency connected with the detection of anomaly. In order to increase the latency optimization, the model is recommendably to implement in the edge of computing devices like Edge TPU or NVIDIA Jetson, which provide the hardware promotion and allow for time sensitivity operation at the outer parts of the network to complete the anomaly pattern identification. The conclusion on the future work for detection zero-day attack in IoT network, the study shows how well autoencoder based anomaly detection system combine the mechanism. It provides a reliable solution that can identify the new threat without the need for the label data, particularly in dynamic and expensive IoT context. Further demonstrate the necessity was seen regarding the feature engineering and data pre-processing in the enhanced model algorithm. Future research can be investigate the use of sophisticated deep learning architecture, including the reinforcement learning or GAN, to further increase the scalability and accuracy of the detection. Additionally, expanding the approach to real-time multi-layered security system and incorporating more diverse IoT attack could enhance the IoT networks. So these are the reference we have taken in our paper, and thank you.
Thank you so much for your presentation, sir. Ma'am and sir, do you have any questions?
Yes, first, this is an excellent presentation. Really, I learned a lot just listening to you. I just have one small point.
Yes, ma'am.
Did you do any work on data balancing? Because just my feeling is your data is slightly imbalanced. Did you do some work about this?
Ma'am, actually the data balancing work, because ma'am, actually the opening we are doing the work, we are getting only less data, ma'am. So we are scaling the data. So as I mentioned, ma'am, the problem is getting data is a very tedious, ma'am, because nobody will give the anomaly data. So how they, no company is ready to give, ma'am, even though they are having. So from Kaggle we are manipulating the data, scaling the data, and we are using. So as you said, ma'am, it is a balance, or even we don't know the thing, ma'am. So whatever the data we are just running with our algorithm and we are getting, but we need a more number of data with accurate data. Then even we can predict whether this algorithm is better, or even we can go for some other algorithm. So that will be a very good thing, ma'am. So we are in a data discrepancy we are having, ma'am. This is a thing, ma'am.
Yes, yeah, very common problem. Yes, thank you very
Yes,
much.
ma'am. Thank you.
So much, ma'am. Sir, do you have any questions?
Not a big question, just what was the data cleaning process and how many data sets you are running for these algorithms?
Sir, for that we got originally 1,200, sir, data. Then we have scaled to up to 3,000, sir. That's all, sir. The data we have taken.
Okay,
So
so
we
out of
need a
the
more number of
3,000 data,
data. We know, sir, but we have the available data. We make it, sir. So still we
okay,
are searching for the data, and we are searching for some other network for MOU in from through our college. We are trying, sir. So then only we
to
can
find out
surely say
the
our
accuracy
algorithm is
of the data.
super, and it will be a very efficient thing. So
Yes, yes.
yes, sir.
Okay. Thank you so much.
Thank you, sir.
Very
Thanks
nice
a lot, sir.
presentation.
Thank you so much
Thank you, ma'am.
for
Thanks a
your
lot, ma'am, for
presentation.
giving me the opportunity, ma'am.
Yeah, thank you so much. So, do we have freedom to present this paper? Do we have Huang to present the paper? Okay then. So I sincerely want to thank our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough for each one of you. I, on the behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. All the papers have already been forwarded to the printer. The publication will be live within 6 months. So kindly cooperate with the team of ICICT 2025. Before ending this session, I would like to take a moment to appreciate and thank our session chair, Professor Sama, for chairing this session. Thank you so much, ma'am. This is a token of appreciation. Would you like to
You're
share?
welcome.
Yeah. Can you share a quick closing remark with us?
Yes, it was actually a pleasure to be in this session. So it was very interesting. Those papers come from all over the world. We would never have met otherwise than this. And all the topics were really very, very interesting. So thank you, everybody, for an excellent session.
Thank you so much, ma'am. This is a token of appreciation to the chair on the behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. I would also like to take a moment to thank our session chair, Professor Navneet, for chairing this session. Thank you so much, sir. Would you like to share a quick closing remark with us?
Yeah, thank you so much for giving me the opportunity to be a session chair in this STEAM conference. And all the presenters, all the authors given a very nice presentations, and they work very hard to prepare their presentations. Thank you so much.
Thank you so much, sir. Thank you so much, ma'am. Before ending this session, I would request everyone to kindly turn on their cameras for a quick snapshot. Thank you so much, everyone. Take care. Stay safe. Bye bye. Bye bye, everyone. Take care.
Love you.